everybody, Harold here. If you watch my video on BizDat, you'll know that I like to get a good look at my data before I begin any analysis. In this video, I'm going to review a fantastic R data visualization package called inspectdf. Inspectdf gives you a great set of tools to analyze and visualize the structure and content of your data. It allows you to inspect different aspects such as like correlations, missing values, distribution, categories and numbers, and more. And best of all, it has really cool plots like this one. So this is a plot of M-sleep, which is available with the tidyverse frequency of categorical levels. InspectDF is a simple package. It only has 7 core functions, a plotting function, and a database thrown in. So let's get to the 7 core functions. And for this tutorial, you can require our library tidyverse library and require equivalent GT. You might want to make some little tables, the results, and our package the main package we're discussing, inspectdf. This plot over here is the result of msleep piped into inspectcat show plot if you want to replicate that. But let's get started with the 7. Number 1, inspect_cat. In a single data frame, this will summarize the levels of each categorical column, show the most common level and its percentage of the category in a table. So Star Wars, pipe that into inspectcat. Of course, Star Wars is your argument because it's piped in, so you don't need an argument for inspectcat. Down here you see it gives us each column name, the count of the most common entry in that variable, and what percentage that most common one is. Some of these are good for GT tables, some of them aren't. I'll show you. So let's try to show it in the table. This one's not that great because of all this. It shows you all the levels and what percentage each level is in a list. Kind of ugly for a table. But you have your column name, your count of most common attribute, count of that, what percentage of that variable is that most common attribute. Of course, like I said, the plots are really cool. So we have inspectcat show plot. Let me drag that back over. So frequency of categorical levels in the data that I piped in, which is Star Wars. Gray segments are missing. The largest ones are actually put the label on the attribute: brown, blue, yellow, black. So these are proportional to how many of these attributes make up that variable. Gender, masculine, feminine, NA, so on and so forth. And I really love the colors on this. So now, the other thing you can do with SpecCat is compare 2 data frames. So I took Star Wars and then the first 20 rows of Star Wars to compare them to each other. And this gives you a table with column name, divergence, which is a measure from 0 to 1. 0 is really agrees with the no changes. 1 is totally different. So this shows you how different your two data frames are. P-value, the lower it is, the more different they are. The rest of this lists out the unique levels and counts like I showed you in that table. It's really not very pretty though. But if you show the plot, I really like these. So Star Wars eye color, brown was the predominant. Star Wars 2 eye color, the first 20 rows, blue was predominant. Same, so on and so forth. But you see how the different data frames compared in distribution of attributes among the variables. And again, I love these colors. So that's inspect cat. Inspect core, summarize and compare correlations for the numeric columns in a data frame. So I'm going to use a GT argument on this one. I think it looks better. So Star Wars, inspect core, pipe in Star Wars, pipe all that into GT. And now we have a correlation table. Birth year and mass have a 0.478 correlation, a low p-value, lower and upper bounds, and percent of pairs that have non-missing values. So birth year and mass, percent of those together that have non-missing. Same with height. So that's a really good quick correlation uh, view in a table. Now I'll show you in the plot. Star Wars inspect core show plot, all piped. So this gives you kind of a box plot, maybe not really, showing you the range of. I guess it is a box plot, no whiskers. Showing you the birth year and height correlation. It's negative zero point 0.4, but this is the upper and lower bounds. Same with birth year and mass and height. So spec core, if you wanted to compare correlations between data frames, do that using the other data frame as your second argument. So Star Wars 1 through 20. Again, we're comparing the whole database, whole data set to the first 20 rows. And that gives you another kind of box plot. First one's red, second one's blue, where their correlations are. Also pretty cool. So let's keep going. Inspect IMB. That identifies and quantifies the imbalance in categorical variables. It's a little different from an inspect cat. Let me show you. So we'll Star Wars, inspect IMB imbalance, then we'll put the GT table in. So our column name, this is just on one data frame. Value masculine was 75% of gender, 66 out of the 83 were gender, so on. Where it really comes into play, if you like the plot, I'll show you the plot first. It's the same as the table, just plotted, nice pretty plot, great colors. Where this really comes into play though is in the comparison. Again, we're going to do Star Wars versus the first 20 rows. So now gender masculine, 75%, total count of 85, 66 and 1, 17 and 2, and gives us a p-value. So it's comparing the counts and imbalances between two data frames. Let me show you the plot on that one. That gives us a nice scatter plot. So percent of column, name, homeworld. Here you're only going to get the numeric one. Well, so percent of column, like for skin color, Star Wars fair was 20%, but for Star Wars 2, it was like 35 or 40%, closer to 40%. Gives you a scatter plot showing the imbalance between the most common attributes in each variable between two data frames. Now, keep moving. The number 5, inspect mem. This one, kind of cool. Not really, well, it might help you uh, It'll help you trim down your database, choose which columns you want to select. Inspect memory usage by variable as a percentage for a single data frame here. So Star Wars mem, inspect mem, GT. So films, that's a big list of all the films everybody was in. So that's huge. 20,008 bytes, 19.54 kilobytes, 35, almost 36% of the database was just films. If you're not really interested in the films, cut it out before you bring it in. Select minus films, so on and so forth. That might help you save some time. Let's plot that. 14 columns, 87 rows, total size, and a visual representation of the memory usage of each variable. If you want to compare data frames, you can also use mem to compare data frames. So in the first one, the size is 19. The second one is of films is 19.54 kilobytes. And the second one, it's only 7.23. But it's a larger percentage of the second one. So there must have been people in the first 20 rows that were in more films on average than the people in the total database. So you can figure things like that. Let me show you the plot on that. I like this one too, of course. Nice bar chart showing you each database and the percentages of the variables memory usage. All right, inspect NA. You know, I'm big on handling missing values in NAs, so this one gives you a good idea of that. Star Wars inspect NA GT. So birth year, there's 44 NAs, 50.5% of the data. Might be a good column for elimination. Mass, 28. Mass is a numeric. Maybe we'll do some imputation. Uh, the rest of these are pretty small. 32% is pretty high. The rest of these are pretty small. Zeros. You can probably just NARM equals true in a lot of these, depending on what you want to do. You could do that. So let me show you the plot. And there it is. Nice bar chart showing the percentage of NAs in each variable. Again, with the nice colors. Spec num gives you basic stats for numeric columns, including min, max, mean, the quartiles, 50%, the middle quartiles, the median, standard deviation, and a histogram. You won't see the histogram in the, this one's really ugly in a GT, so we're not going to do that. You won't see the histogram here, but see the rest of it. So height, minimum height, 66, max height, 264. This is centimeters. Quartile 1, 167, the median 180, the mean 175, quartile 3, 191, max 264, I already said. 34.8 standard deviation, and the percent of NAs is 6.90. So that's great statistical summary right there. These lists are all levels and counts, and they really mess up the tables. That's why I don't do them. But I really do like the histogram. So each numeric column, I'm going to zoom this one, gets its own histogram showing the distribution skewness, if you will, of each numeric column. So that's pretty. Like that one. These are all great, I think. And last but not least, inspect types. This just gives you an idea of the, it's like a VisDeck, the distribution of data types in your data frame. So I'll put this one in a GT, Star Wars inspect types, GT. So we have 8 characters to make up, 8 character variables, make up 57.1% of the data, and they are these, and so on and so forth. 3 lists, 2 numeric, and 1 integer. And this is my favorite plot of them all. Ta-da! I love this little rainbow circle chart showing the distribution. I don't know why. And the larger ones have each pie section has the variable name around it. Let's zoom on it. Each wedge is proportional to how much that of the database it is. And there's a count of columns of that type inside the wedge. It's like a weird pizza. Okay, so that is it for inspectdf. Hope you like this one. I got a couple more of these. I'm going to do one called Vim next. But I hope you liked this one. If you did, please like it, subscribe, and I'll see you next time. Thanks, everybody.